Good afternoon, everybody. I'm Lisa. I'm first year PhD student at the University of Birmingham, and today I would like to present you a little bit about seasonal weather forecast. About their development, why do we need them, and then I want to go especially on their role of extreme event prediction, especially for severe windstorms, which is part of my thesis project. But first of all, what is seasonal prediction? I think all of us know that we have the weather forecast on the one hand side, which is predicting up to a few days, up to a bit of a week. And on the other side, we have the climate projections, which forecast the development of decades, but into next centuries. And in between, we also want to know what's going on in the next month, up to the next season, maybe almost into the next year. So this is doing by the seasonal to interannual prediction. What forecast systems do we have? I would like to present you two different institutes. First of all, the UK Met Office. They're working with their global seasonal forecasting system, version 5 already, shortly the Glossy 5. They're working on this since the 90s, so quite a bit now. But what are they working on? So there are two outputs of the model. First of all, of course, the forecast itself. So the UK Met Office is running their model every month, and they're running it for the next 3 up to 7 months to see what's in the next season going on. But they're also producing a hindcast dataset. This is very, very good to use for performance studies, skill studies. So this is a dataset where you use the current model and go back into the past and pretend you don't know what's going on, and forecasting the last year's seasons which already happened. So you have then a bigger data set with the forecast of all the seasons with one current model, the hindcast. And who's needing this? So the Met Office website telling us very nicely which are their end users. So for example, they stated out that they're doing this for decision makers like in the politics, but more interesting, the agriculture. So they need to know, how's the weather next season? Is it drier? Is it wetter? Is it warmer? Is it colder than usually? So then they can decide which crop they want to plant. And they also stated, the Met Office also stated, that the climate extremes are one very big issue in the seasonal scale. So for example, for summer, we have the heat waves, which need to be predicted. And for winter, we have more like the storms. So this varies in the seasons. So the prediction of the accuracy of hazards is a very big part of the seasonal forecast. So this leads to the reinsurance sector, who is a big user of this model output. The second institute is the ECMWF, the European Centre of Medium Range Weather Forecast. They are also in System 5 with their seasonal forecasting system, and this is based on their integrated forecasting system, IFS. Maybe some of you heard about it. And they developed their first version of the seasonal forecast also in the 90s, so around 1991. And also here we have some nice statement who's their end users. Here we are again with agriculture, water management, but also energy is a big part. So is there enough solar radiation? Is there enough wind to produce energy, or do we need other energy sources to have enough for everybody? And they also nicely quoted that the seasonal forecast is important to prepare for potential periods of extreme conditions. So let's see how these models perform. Therefore, I brought you here a study about the NAO, the North Atlantic Oscillation, which is the main driver of the European weather. And the variability of this indice is also on a seasonal scale, so it's quite important to have this value as good as possible in your seasonal forecast model. So I know there's a lot of color on here, but focus on the black solid line, which is the reality. The bluish lines are two versions of the UK Met Office, and the purplish is the ECMWF System 4. So shortly, if you look here, where we have like a very good performance of the models, there's quite an agreement in the values, but we have also other years where we have quite a disagreement. So there's quite not the good performance. To have a little bit of a value another study stated out that the glossy 5, the Met Office model, has a correlation to reality of a value from 0.62, what's quite good. So let's continue with extreme events. We have I brought you a paper from Degenhardt et al., which established the performance of different seasonal forecast models. First of all, for all cyclones, which means all lower pressure systems appearing. I want to focus only on British Isles, so have a look into here. The middle model is the ECMWF system 4, shows a quite good correlation to the realities. So a good forecast. The glossy 5 also shows with a yellowish color positive correlation, but not significant so far. When we go more in extreme events, like the extreme cyclones, which means the 5% stronger cyclones, then we see that the ECMWF systems drop totally in their skill performance. The glossy 5 also drops, but has a little bit of significance still there. When we go way stronger into windstorms, which are the 2% strongest wind events, then we see again some very good prediction of the glossy 5 around the European country. And this is kind of the basic for my PhD thesis. So let's wrap up my presentation and summarize. The seasonal forecast is a time range in between the known weather forecast and the known climate projections. But we have various phenomena on the seasonal scale, especially the extreme events. We really want to know to predict, because people living in regions which are influenced by extreme events, reinsurance companies want to know what's going on. And at the end, we saw a little bit of my first results, which show positive predictability for storm frequency and intensity, especially over UK. So thank you for your attention and for listening. I'm happy to answer questions now during the conference, or drop me an email. I'm happy, to chat with you. Also, like Twitter. Enjoy the conference. Thanks.